For example 2, we're going to start introducing variables. So this is where we're going to start introducing how to factor polynomials. So example 2 says, what is the greatest common factor of 3x and 9x squared? So what I'm going to do is I'm going to write these vertically because it's going to help us to see the greatest common factor. So 3x and 9x squared. And what we're going to do is I'm going to expand these and show you how to find the greatest common factor with the expansion. Eventually you won't have to expand them, but I think initially it might help. So 3x, if we expand that, that just means 3 times x. 9x squared, I can expand this and I can think of my factors of 9. So I have 9 times 1 and 3 times 3. Because 3x, since 3 is prime and we can only use 3, I'm going to use these factors in my expansion because I know that we're using 3's anyway. So 9 is 3 times 3, and then x squared is x times x. And so here we have 3 times x and then 3 times 3 times x times x. And with this expansion, it's easier for me to see the greatest common factors because I want to know what's the same, what are the same factors for both of these terms. So they both have a factor of 3. They both have a factor of x, and that's all that's the same, right? This has an extra 3 and an extra x, but this one doesn't. So we can't say that they're common factors. So for this one, our greatest common factor happens to be just the common factors, which are 3 and x, which is 3 times x or 3x. So the greatest common factor is 3x. And for the variable part, they both have to have the same variable. So they both have 1x. Okay, let's look at example 3. And again, I'm going to write these vertically so I can expand them. So we have 6x squared y and 9x cubed y squared. And I'm going to expand them. And as I expand them, I'm going to be thinking about the numbers and the factors that might be common factors for 6 and 9. I know that they both have 3 as a factor, so I'm going to use those factors to help me determine the greatest common factor. So 6 is 3 times 2, and then x squared is x times x, and then times y. 9 is 3 times 3. X cubed is x times x times x, and then y squared is y times y. So this is the expanded way to write it. And then as I'm looking for the greatest common factor, I want to first circle the common factors. So 3 is a common factor. They both have 2 factors of x, so x times x and x times x. These are common factors. Notice that they both have 2 x's there. And then this one only has 1 y, and so we have 1 y here. So those are common. So the greatest common factor is 3. And then they both have 2 x's, so that's x squared, and they both have 1 y, so that's y. Okay, so expanding them will help you to see the common factors, and then from there, the greatest common factor. All right, and our last one, I'm again going to write these vertically. So I have 2xy squared z cubed, 3x squared y, and then 6xz. So for my first one, 2 is prime, so that's just 2 times 1, so I'm just going to use 2 because we never use 1 as a greatest common factor because it just doesn't make sense. When you multiply 1, you're still going to get the same answer. So we have 2x, and then we have y squared, and that's y times y. And then we have z cubed, so that's z times z times z. 3 is prime, so 3 times 1, but I'm not going to write the 3. X squared is x times x, and then times y. And then 6, I can use 3 times 2, and then x, and then times z. So now I'm looking for my common factors. Do they all have a 2? No, these two do, but since this one doesn't, we can't use that. Do they all have a 3? No. So this means that there's no greatest common factor for the numerical part, and that's okay. You're not always going to have a greatest common factor for all numerals or all variables. So we're just going to not have a numerical part, and that's fine. Do they all have one factor of an x? Yes. And do they all have one